Again, introducing dun, 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 logarithmic function. We're going to rewrite it from exponential function to exponential form to logarithmic form. Why do we need a logarithm? So let's look at this. The inverse of x squared is square root, right? Everyone agree those are inverses? You're like, I don't know how to type that. The inverse of x cubed is cube root, right? We could do all of these. I could do this all day long. But what about the inverse of an exponential? Okay, I'm going to do base 10. The inverse of base 10 is log base 10 of x. Okay, you don't have to understand how I got that, but that's why we need a logarithmic function, because I don't know what root to take. Okay, you're going to want to watch this whole video. Okay. Okay.
I still gotta watch the one from last week.
Okay.
Thank you.
Bye-bye. Thanks, you too. Okay, so how do I rewrite the equation into in logarithmic form? So we have a to the x equals b. And I don't know if I used the same letters in that order last year, but okay, let's do an example. Log base 5 of 25 equals 2. Oh my gosh. Should not have my phone under the computer. Okay, are you ready? So the logarithmic is saying what is the exponent? Yeah. 5 to the 2 equals 25. So do you see how the logarithm isolated the exponent on the other side? Now, this looks super confusing, and that's okay, because as we practice, the light bulb's going to go on. Okay, this is super doable. This is one of those things that looks really confusing at the beginning, and then you're like, really, that's it? And then you're going to say, why didn't she say that in the first place? Okay, it just takes some repetition to get in. Okay, so this is the base. This is the exponent. And the, okay, you guys, I hope you're doing this in pencil. I think I want to switch these letters. Okay, let's switch these letters. I am so sorry. And this is the answer. That way they're going to match. So for example, 5 squared equals 25, right? Okay, so what is the base? The base is 5. Okay, what is the exponent that I'm calling x? What is the exponent? 2. What is the answer? 25. Okay. Okay. So here we go. We're going to translate this into logarithmic form. Log, the base goes here, the answer goes here, and we have now isolated the exponent. Okay, the first one we do is going to be a little confusing, but it's all about the base, no trouble. Yeah, sorry. Okay, here we go. Everyone, log. What is the itty bitty subscript right there? The itty bitty subscript is all about the base, no trouble. Okay, 14. Yeah, the 14 goes there. Everyone see that right there? So right here is going to go what? One over 196. That is the answer. Yeah. Awesome. Good job. And I have now isolated the exponent. So what goes alone on the other side? -2. Okay, that's the hardest one. Yeah, let's do another one. Okay, convert this from exponential form and you're like, well, this is weird. Oh, really quick on this one. Did you notice when the exponent is negative, cross the line, change the sign? Yeah, it's a good thing we've been practicing that. Okay. Stop. Okay. Rewrite in logarithmic form. Yeah, well, it's a good thing that you can use notes on the test. But as we practice, this is going to get better. It's going to make more sense, especially when we get to the calculator part. So exciting. Okay. Log, what's the little bitty subscript? All about the, no trouble. All about, yeah, all about the base. Little bitty subscript. The font is smaller. Okay, what goes here? Yeah, 400. And I have isolated the what? Exponent 2. Okay, it's going to get better. Okay, now let's talk about solving. We're going to come back to logarithmic form later. Now, we're not solving this using logs. We're solving this. What do you notice? Okay, first of all, let's cross the line, change the sign. Okay, I don't want to deal with a fraction. So 625 to the -2x is equal to 25 to the -1. Okay, cross the line, change the sign. Now, I happen to notice that 625 and 25, time to look at the Okay, I swear I have one of these that I've tilted. Yeah, what do you notice about 25 and 625? They are both, how do I say this? They are both powers of what? Powers. They are both, there's going to be an exponent involved. They are powers of 5. Does that make sense? That 25 and 625 are powers of 5. And yes, an exponent is involved. 5 squared is 25. 5 to the 4th is 625. 5 to the power of 2 is 25. 5 to the power of 4 is 625. Therefore, 25 and 625 are described as powers of 5. Okay, and this vocabulary is going to help remember it. Are we good? That 25 and 625 are powers of 5. Okay, let's go back. I didn't hear an amen, but we're going to go back anyway. Okay, so I rewrite 625 as 5 to the 4th. And I rewrite 25 as 25 to the second power. Are we good? Yay, I got a yes. Otherwise, it's crickets. Okay. So now we learned something before Thanksgiving, which of course you all remember. If are the same, then are the same. Sorry, I don't like words. If are the same, that, oh, I'm saying are the same. You need to stop. Okay. If the bases are the same, then the exponents are the same. Yeah, if the bases are the same. So this is, so step 1, I want the same base. Step 2, if the bases are the same, then the exponents are the same. Step 3, bring down the equation. Okay. You know what? Let's do a little baby step because I don't think we're quite ready. In the future, we're going to skip this. Does everyone see that this is 5 to the negative 8x is equal to 5 to the negative 2, right? Superpowers, base to the power, multiply, multiply. Okay. Now, time to bring down the equation. Can anyone tell me what the equation is that brings down? If the bases are the same, ding, 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 the 5, poof, it disappears because I can now write an equation with the exponents. Negative 8x is equal to negative 2. Next step, divide by negative 8. X is equal to, is it 4 or 1/4? It is positive 1/4. Oh, careful. Oh, it's a trick question. Yeah, the 8's on the bottom. Yeah, I said that because So many people, they're like, oh, x equals 4. Whoa, 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 look closely. 8 is on the bottom, 1/4. Okay, so get the bases the same. If the bases are the same, then the exponents are the same. Bring down the equation. Okay. Jumpy, jumpy, jumpy. Okay, so I'm gonna go a little faster. 36 and 216. I check the chart of powers and I see that they are all 216 and 36 are powers of, anyone have a guess? Ding, 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 6. So I would have 6 squared. And up, cross the line, change the sign, right? 216, okay, is replaced with 6 to the -3. Are you with me? Because 6 times 6 times 6 is 216. But because I had to cross the line, change the sign, if it was 216 on the bottom, when it comes to the top, the exponent becomes negative. Okay. Now I am going to distribute that 2. Yeah? See what I just did? And I'm going to multiply. Yeah, superpowers, multiply exponents. That is why every week in your attendance quizzes, we've been practicing exponents. So I'm going to multiply those and I'm going to get positive 3p. So I have the same base. Next, if the bases are the same, then the exponents are the same. And now I solve. Okay, who do you want to move? Depends on how comfortable you are with negatives. Okay, which term should we move next? There's 2 ways you could go here. Let's do it. You know what? -2/3. Okay, I'm gonna do it this way. Minus 3p. 3p plus 2 is equal to 0. Instead, you could move the 6p and it would be 1 fewer step, but they're going to be negative. Subtract 2. 3p is equal to -2. Divide by 3. P is equal to -2/3. Okay, so you're going to go to the table of powers. Go to the table of powers and get the same base. If the bases are the same, then the exponents are the same. And then bring down the equation. And we got P equals -2/3. Okay, this one is going to be, oh my gosh. This one is going to be on your own. Okay, simplify. This does not mean plug it in. We are not in 6th grade. That does not mean give me a decimal. Okay, so this is how we're going to do this. We are going to split this into the biggest perfect square and the leftovers. BPSQ and LO. Biggest perfect square and leftovers. So 8 is 2 times 4. That's it. Okay. And 1 times 8. The biggest perfect square is 4. That means the factor that goes with the 4 is the leftovers. Okay. So one of these can be simplified. Yeah. Square root of 4 is 2. The leftovers stay in the house. Okay, so we split it into the biggest perfect square and the leftovers. Now you will see Canvas quizzes. Okay, the Canvas quiz will say, what is the biggest perfect square and what is the leftover? You know, I realize you could just photo math this. Okay, or if you have a Casio, it'll simplify it for you. But the Canvas quiz will say, what is the biggest perfect square? So on the next test, you have to use My Texas Instruments, not a Casio. That'll simplify those for you. Okay. 216. Uh-oh, it's not on the chart, but it looks familiar. 216. Okay, so what do we do if it's not on the chart? Okay, 216 is not on the chart of factors. The chart of factors only goes to 100. Ooh, we could do it that way. There's 2 ways to do this. I need the biggest perfect square and the leftovers. Here's one way to do it. One way to do it is with your calculator. 216 divided by 100. Okay, gives me a decimal. Cross it off. 216 divided by 81. Decimal, cross it off. 216 divided by 64. Okay. You know what? I'm looking at my notes from last year, and I did do it that other way. But we're going to do it both ways. 216 with the calculator divided by 49. Nope, decimal. Okay. 216 is 36 times 6. Does everyone see how I got 36 times 6? This is the list of perfect squares. I actually like this way better, but we're going to do the other one too. Okay, so 36 is the biggest perfect square. And 6 is the leftovers. Does everyone see how 36 is a perfect square? 6 is not a perfect square. Okay. The square root of 36 is 6. So I have an inside 6 and an outside 6. I like that method. Okay, you take all your perfect squares and you see what is the biggest one that goes into 216. Now, sometimes, in fact, last year's video, sometimes I do this. 216, let's make a factor tree. 216 can be divided by 2. 216 divided by 2 is 108. Prime number. 108 can be divided by 2. 108 divided by 2 is 54. We got another prime number. 54 is 9 times 6. Ah, I got a perfect square. Perfect square is better than a prime number. So I'm going to put these two together because I want perfect squares. Can we see that this is 4, 9, and did I forget anything? So here's method number 2. We could break it down into little perfect squares. So 216 is 4, 9, and 6. Do we like this method better? Okay, the square root of 4 is 2. The square root of 9 is 3. And 6 is not a perfect square. 6 square root 6. So you have two different methods. One is making a factor tree, and one is using a calculator and dividing by all your perfect squares, starting from the bottom up. Okay, so you need to know the process. And in the Canvas quizzes, if I say, what is the biggest perfect square? You have to be able to tell me, not just the final answer. Okay. Question. 9 is 3 times 3. Yeah. So I took a shortcut. And then 6 is 3 times 2. So the perfect squares, I could put these two together. I could put these two together. And then these are the leftovers. So some people like this method. I don't really like, I think this method's confusing. I like this one. I would say do this one. Okay. Next topic, knowing that this is a week's worth of math, including some review. Okay, inverse. Now, the variable, what is the variable in this problem? The one variable is x. What is the function name? In this problem? The function is function f. It is not a variable. Okay, so the inverse of f is written like this. Now, this is a one-step problem. Okay, once we're going to do this whole long process. Actually, if it's a one-step problem, we're not going to do the procedure because I want you to know what it means. So I take a variable and I add 4. The inverse is take a variable and do the opposite. Subtract 4. The function says take your numbers and add 4. The inverse says take your numbers and subtract 4. So this is what inverse is. Like if you are wrapping a present. The function would be put it in a box, cover it with paper, put a bow on it. Yeah. The inverse would be unwrapping. So the inverse, you would take off the bow, right? That's different than putting on the bow. You would take off the paper and then you would take it out of the box. So for an inverse function, you undo everything. Now, if there's more than one step, can you see that subtracting is going to be involved somewhere? I want to find G inverse of X, but there's more than one step, so I have to use this procedure. There's going to be parentheses involved. It's going to be complicated. Notice that is not an exponent. When it's not on a variable, it's on the function name. When it's on the function name, it's not an exponent, it's inverse. Okay, so here we go. Using the procedure, change from g of x to y equals. Switch. Okay, some of you may remember. No, I'm not going there. Okay, switch the x and the y. Actually, I will go there. In geometry last year, when we did those transformations, that was the rule for reflecting across the line y equals x. You switch your x and the y. So you probably don't remember. Okay, so everyone with me, you start with changing from function notation to y equals notation, switch your x and the y. Now solve for y. Okay, so to solve for y, the process of solving for y is to do the inverse of each one. Next step, subtract 5. Yeah, do you see how the inverse is appearing? Okay, so I'm gonna multiply by the reciprocal. So I'm gonna multiply by 2, divide by 5. Multiply by 2, divide by 5. Cancel. Y is equal to 2/5 x minus 5. And you might leave it like that, or you might distribute. Okay, last year I went ahead and distributed. So 2/5 x. Now I need to take 2/5 and multiply it by 5/1. And what do I get? 2. There we go. In slope intercept form, the inverse. Now, if you graphed these, it would look interesting, and it would look kind of like last year in geometry, reflecting across the line y equals x. That's for another time. Okay, do not do. We'll talk about guess and check later. Okay. Evaluate. Step 1, put equal to x. So there's 2 ways to do this. One is to change it from log form to exponential form. And the other is a really cool trick with the calculator. Okay, so we're going to go from exponential form. Sorry, we're going to go from log form to exponential form. What is the base? Right there? Yeah, 5. 5. What is the exponent? Yeah, over there. And what is the answer? 1/25. Yeah. Okay, let's get a common base. 5 to the x equals 1/5 squared. Doing this the long way. Five to the x equals 5. Cross the line, change the sign. So x is equal to -2. Okay. Equals x. Rewrite this from log form into exponential form. Base, exponent, answer. Okay, I look at the chart of powers and I see that 81 is 3 to the 4th power.
Oh, hello.
Hello.
Is that for,
Advanced algebra.
oh, and geometry?
Yes. So 3 to the x equals 3 to the 4th. If the bases are the same, then the exponent is the same. Okay, how are we doing on these particular problems? Okay, now, do we want to see a calculator version? The calculator will only do base 10. The calculator does not do base 3. So this is called the change of base formula. Okay, you do log of the answer divided by log of the base.
Okay, I'll write this down.
Oh, no, don't worry about it. You'll see it next year. Which is log of 81 divided by log of the base, which is 3 with parentheses. If you plugged that into the calculator, you would get 4. Now, you may look at that and go, that's worse. But with practice, people tend to really like this method, believe it or not. Log of the answer divided by log of the base. It gets faster.
This one.
I actually like logs. Okay, we don't need to practice this one. Do not do. Because